Have you ever stopped to think about how your brain makes those lightning fast decisions? The ones you make in literally the blink of an eye? Well, we're going to dive right into that fascinating process and take a look at a really cool theory that helps explain how it all works. So first up, let's just get a feel for how incredibly fast our brains are at sorting and labeling the world around us. Think about these situations. Your brain is already on the case before you're even really aware of it. You spot a figure in the distance. Instantly, right? Your brain does this primal split-second calculation. Friend or foe? Okay, a new email lands in your inbox. That subject line, the sender, your brain just knows. It flags it as either important or total junk. It's basically the modern digital version of that same ancient judgment call. You're about to cross a street and you hear a sudden noise. You don't have time to sit and analyze it. You just know instinctively whether you need to jump back or if it's okay to keep going. I mean, our survival, or even just our daily convenience, really depends on these instant choices. But what is actually going on behind the scenes? How in the world does the brain pull this off so smoothly? That's the huge question we're going to get into.
To really understand the how, we've got to have the right words for it. And of course, scientists have a specific name for this mental superpower.
And that term is speeded categorization. It's not just about being quick, it's about making classifications, sorting things into mental boxes like safe or dangerous, especially when you're under pressure and there's no time to weigh every single option. So how can we explain speeded categorization? Well, one of the main ideas out there is a really intuitive concept called the information accumulation theory. Let's break down how it works. The purpose of this theory is stated perfectly simply. It is, literally, a model for speeded categorization. Its whole job is to give us a framework for the exact process we've been talking about. So let's pop the hood and see what's inside. This right here is the core idea. Just think of your brain as filling up a bucket. Every little piece of information you see or hear is like a drop of water. Your brain just keeps accumulating these drops until, whoosh, the bucket is full. The second it hits that decision threshold, bam, the judgment is made. So for that friend or foe decision, the drops of water might be the person's posture, how fast they're walking, what they're wearing. For the spam email, the drops are things like a weird sender address, a generic hello, or typos in the first line. Your brain isn't slowly analyzing each piece. It's just collecting them super fast until it has just enough info to confidently yell spam or safe. And hey, this isn't some brand new idea. It was formally published way back in 2000 by K. Lamberts in the super prestigious Psychological Review, which really gave the whole concept a solid scientific foundation to build on. Now, as with any big scientific question, one theory is never the whole story. So it's really important to see where this idea fits into the larger conversation about how our minds actually work. I mean, trying to decode our own thoughts is a massive undertaking. The information accumulation theory is a really powerful tool for sure, but it's just one of many that researchers are using to try and map out the super complex landscape of human thought. For instance, while our model focuses on that gradual buildup of evidence, filling the bucket drop by drop, there are other approaches out there. Some other theories suggest different ways it might work. Maybe our brain instantly matches a new situation to one specific memory it already has stored away, instead of building a case from scratch. Science absolutely thrives on these different viewpoints, with everyone working to find the best possible explanation. So, what does all of this mean for the future? Well, understanding snap judgments is still a huge frontier in cognitive science, which, leaves us with a really fascinating question to think about. And this is really the question that's driving all the research forward. Is it better to focus on perfecting one single model to understand every little gear inside it? Or do we actually learn more by stepping back and comparing all the different maps, all the different theories? What do you think is the best way to truly understand the mind? That's a great thought to take with you. Thanks for joining this explainer.